Welcome to the second part of this big tutorial series that will show you how to make a mixed reality game for the meta quest in Unity. Now, after doing the XR setup and making this cool ray gun in the previous episode, in this video we are going to make the star of the show, the ghost. Not only we will build the ghost together in Blender and make the ghost shader using shadergraph, but I'm also going to show you how we can use the player's real-world information to spawn the ghost behind the wall. Now, if you haven't already, now is a good time to subscribe because in the next episode I will show you how we can create a nav mesh to let the ghost move and avoid obstacles in the real world to reach the orbs. As always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content. And now this entire series is sponsored by Connective 3D. Connective 3D is a free tool that allows you to collect data in your game to better understand how it is being played. With Connective 3D, you can watch replay of your player, get comprehensive data about their session, know if your game meets your objective with its objective system, and so much more. Now, I've previously featured this tool in a super complete tutorial on this channel that I will link in the description, so don't wait any longer and register for free with the link you will find down below. So, without further ado, let's get started with our tutorial. And there it is, guys, we are where we were left at the end of last episode with our beautiful ray gun. Now it is time to make the star of the show, the ghost. And for this, we are going to make our own 3D model in Blender. So be kind, please, because yeah, it's the first time that I'm using Blender for a tutorial. So anyway, if we open Blender, which you will be able to download in the link you will find in the description below, there you go. We have three things here. A camera that we can delete if we right click and then click on delete. Do the same for the cube and the same for the light, and we should be left with an empty scene. Beautiful. But now to create the ghost, we are going to first create a sphere. So we can go at the top, add mesh, and there we are going to add a new V-sphere. But as you can see, the sphere is not very much detailed. So what we can do is go up there, and what I'm going to do is write 64 and then 32. Basically, as you can see, this will double the amount of quad that are on the sphere right now, which will make it a bit more defined. Now, anyway, you can see that the shading is a bit weird right now because it shows all of the little squares. So what we can do is actually right click and click on shade smooth. And as you can see, it is super smooth as the sphere should be. So that's really nice. Okay, so now it is time to do some 3D modeling. So what I'm going to do is press on the tab key, and as you can see, we have now showing all of the little vertices of our 3D model. And what we are going to do is actually select the 3D model at the end right there. But if we press on the G key, as you can see, we can move the vertices, but not the one that are around it. So let me press on Ctrl Z to go back to where we were. And what I'm going to do to fix this is click over there. Now, as you can see, if I press on the G key, you can see that there is a kind of big circle now. And if you scroll, you can actually change the size of the circle. And this means now that you are able to move all of the neighbor of the vertices that you are grabbing. Now, let me press on Ctrl Z because we are going to use this exact technique, but we are going to use it on a certain axis. So follow as I'm doing here. You can press over there. Then we are going to click on the scroll wheel to go on this side, and we can press on the Y key. This will force us to have this view where the X direction is on our left and our Z direction is upward. This means that now with the vertices that we have selected, if we press on the G key, we can move it and force the movement to be vertical, which is what we want. And there you go. If we increase a little bit the size of the neighboring effect, there you go. If we left click, this is what we have left. We have successfully managed to edit our beautiful shape like we want it. And I guess that this is already nice, but I think it would be also great to add some arms to the shape. So let's go to the X view over there to face the ghost forward. And what we can do is select one of the edges again, press on G. Now I'm going to reduce the size and we can go to the left to create some little arms for our ghost. We can do the same with the other edges at the opposite side and move it like this. And there you go, our ghost is made. And as you can see, it already looks good. For the eye, don't worry, we will set up them inside Unity. But I think already with this, we have kind of a ghostly shape, which is kind of nice. So let's select this shape over there. We can actually rename it Ghost. And I'm going to go to File, Export, FBX. There you go. Make sure that the limit is set to selected object. And now we can save the 3D model anywhere that we want to. Congratulations, at this stage, you've managed to make your own 3D model using Blender. So we can simply select it over there and drag it inside Unity, right there, and we should see it. There we go, we have our ghost showing. That's beautiful. I'm going to drag it in the hierarchy, and we can see it over there. But as you can see, our ghost is a little too big, but for some reason the scale is set to 100, so let's set it back to 111 on all axes. But now it is a bit too small, so what we can do is actually go to the ghost model, and on the scale factor, I'm going to set the scale to 10 and then click on apply. And there it is. We have our beautiful ghost, which we can scale as we want. But as you can see, the forward axis of the ghost doesn't point into the blue axis. That is this one right there, which I don't like. So what we can do is actually right click on the ghost and click on create empty parent. Now, as the name suggests, this will create an empty parent for our ghost, which we can call ghost. Beautiful. And now we can take the child, and what we want to do is rotate the child so that it points into the blue direction that we have on the parent. So let's select it right there and rotate it 90 degrees on this direction. Beautiful. So the direction should be minus 90, 90. And here you go. Now, if we have a look at the parent, this is what we have. We have a beautiful 3D model that has been correctly scaled, but also that has a correct forward axis. Now that's beautiful, but something is missing on the ghost, and it is, of course, the eyes. So for the eyes, what we are going to do is use here this simple 2D image that I've quickly made on Photoshop. You should be able to download it in the description down below with as well the ghost 3D model if you want to use the exact one that I'm using right there. We can drag the eyes in the Unity project. And what I'm going to do is right click on the ghost, go to 3D object, and then go on quad. Beautiful. Now, as you can see, this creates a quad, which we can rotate 180 degrees, that we can scale down, and that we can place in front of the ghost, like so. And now what we can do is drag here the ghost eyes on the quad that we just made, and this should by default create a material. So right now the material is the ghost eye, which you can see right there. But as you can see, the shader is set to universal render pipeline lit, which is something we don't want. So let's go to universal render pipeline and set it to unlit, because we don't want it to have any lighting information. For the surface tab, we want it to be transparent right there. And now, as you can see, this seems to work well. We can scale the eyes like we want, put them like so. And there you go. As you can see, our ghost has some beautiful eyes right now. But of course, right now, the ghost material is not down. So this is what we are going to do by simply creating our own shader using shadergraph. Okay, so to create our own shader, we can right click in the project windows, create, then we can go on shadergraph above, and then we are going to go to URP and select the unlit shader graph. Because you want a shader that is not lit, we can call this one ghost shader. Beautiful. We can then click on open shader editor. And this is what you should see. So this is the shader graph, which will allow us to create some shader by dragging some nodes. And you will see we will make a very, very simple shader. But first we need to do some settings on the window that you should see over there. And the only setting that we need to do is set the surface type to transparent. Beautiful. Now for the shader itself, what I'd like to do is create a ghost Fresnel effect. So I'm going to right click, create node, and search for Fresnel. Beautiful. Now already, if we drag this Fresnel effect to the base color and that we save, there you go. Now let's create a material with this ghost shader. For this, we can right click on the ghost shader, go to create, and then on material. And as you can see, by default, this will create a material that has the ghost shader because we have right-clicked on the ghost shader. We can rename this one ghost material and we can assign it to our ghost. And as you can see already by default, we have a very, very nice effect. But at this point, something a bit annoying is that we have no settings here to tweak the look of our effect. So what we can do is go back to the ghost shader and add some settings over there. Now, the first setting that I'm going to do is here, you can see that there is a power float. So if we click on the plus button, float, I'm going to call this one power. We can drag it over there and drag the power node to the power variable. And now if we save and go back to Unity, you can see that now with the power setting, I can change the intensity of the Fresnel effect. So that's one good thing. Now, if we create not this time a float, but a color, which we can still call color, and that we drag it over there, what I like to do is change the default color of the Fresnel effect. And to do so, we can actually multiply the result of the Fresnel effect by the color. So let's right click, create node, search for multiply, press on enter, drag the color for the first variable and the Fresnel effect for the second one. And then with the result that we have, so the output, we can override the base color that we had. And basically just like this, if we save, go back to Unity, you can see that everything is pitch black now. But if I change the color to something, let's say, yeah, bluish, as you can see, this works. Now I have two settings. I can either change the color of the Fresnel effect, but I can also change the power itself. But as you can see, there is an issue. The issue is that our ghost is not transparent. And what we'd like is to, instead of having a black color on the inside, we want this color to be transparent. And this, we can do so if we go back to our shader. Now let me do a rectangular selection over there and drag everything to the left to make some room here. And what I'm going to do is use the alpha value of the color that we have here for the alpha parameters over there. So let's right click, create node and go to split. And if we drag the output over there, this means that we can split the color into the four components of the color. So RGBA, A being the alpha channel. And if we drag the alpha channel to the alpha value on the shader and that we save, as you can see, everything is transparent. But if we go to the color and that we increase the alpha value to the max, as you can see, this is working now. And now with everything, we can tweak the transparency, the power effect, as well as the color. As you can see, everything is working super nice. You can even make a red ghost like this. I think the effect looks really great. Now, anyway, at this point, we have succeeded to create our beautiful ghost 3D model with the beautiful eyes, with the beautiful shader. So congratulations. But now this is the second part of this tutorial, which is very important. And it is how should we instantiate this ghost inside the player's environment. Okay, so to post our beautiful ghost over time, what I'm going to do is drag the ghost in the project window to turn it into a prefab. This way it will save us into the file of our game and we can remove the one that we have here. I'm going to right click, create empty and create a ghost spawner. Beautiful. We can add as a component a ghost spawner component as well. And here for the position of this game object, let me reset it to 0, 0, 0 so that everything looks a bit better. And let's open this script inside Visual Studio. Okay, so if you wanted to spawn a prefab over time for a traditional game, which is not XR, this is what you would do. First, you get a public float spawn timer, which we can initialize maybe to 1 second. Then you will use a private float timer to count the time that is passing. And you will have a reference to the prefab that you want to spawn. So the prefab to spawn. And simply using this value in the update function, what we can do is increase the timer with timer plus equal delta time. And if the timer is greater than the spawn time, this means that we can instantiate our ghost. So I'm going to write a new function called public void spawn ghost. And inside this function, if we wanted to make a traditional non-XR game, what we could do is simply instantiate our ghost prefab with instantiate prefab to spawn. There you go, and we could call here the spawn ghost when the timer is greater than the spawn times. And then we can reset the timer by doing timer minus equals spawn timer. Beautiful. So if we wanted to give a random position to our ghost just to test, we could do, for example, vector3 random position equals random dot. We could do inside unit sphere and multiply by a certain distance, like 3. So this means that the random position is somewhere inside a sphere that has a radius of 3. And maybe what we can do is set the y to 0 so that it is on the ground. And now we can instantiate the ghost at the random position. And for the rotation, we can do quaternion.identity. Beautiful. And there we go. We can save our script as simple as this and go back to Unity. And now let's find out how this default spawner would look like and why it won't work for our mixed reality game. Of course, don't forget to drag here our ghost prefab inside the prefab to spawn. And there you go, if we click on play. As you can see, it is working. One ghost is spawning every second, but as you can see, because we have made a random position, well, sometimes in some cases, the ghost doesn't spawn inside the room, sometimes it spawns inside furnitures, sometimes it spawns in some places where it might be stuck, so this is of course a big problem, and this is what we can actually fix by reading some of the data from the scene model. Let's leave play mode, and here what I'm going to do is actually update the ghost spawner to take into consideration the scene model. Now, in my case, I want the ghost to spawn behind the wall of the player so that the ghost could go through the wall like a ghost and eat an orb that will spawn in the room of the player. Now, before showing you how to do this inside the ghost spawner, I highly suggest you to do the following. If we right-click, create empty, and that we search for find spawn position, you can see that there is already a script that is made by Meta that actually finds some spawn position. As you can see, you can set the spawn location to be floating, vertical surfaces, hanging down. You can set the different labels of where you want the spawn to occur. You can set the max iteration in case it fails and you want to iterate again for a new position. We are not going to use this script inside this tutorial, but what I highly suggest you to do is read a little bit of it to understand how some of these elements can be done, because the script is really well made in my opinion, and it actually uses also the size of the object to know where it needs to spawn. But we are going to do a simpler version than the script, so anyway, let me select the game object that we created, delete it, go back to the ghost spawner and open the ghost spawner script. Okay, so let's get started on the random position. So the first thing that we want to do in the spawn ghost is do MRUK room. And now the MRUK room is not recognized because if we click over there, you can see that we need to write at the top using meta.xr.mrutilitykit. So let's do so using meta.xr.mrutilitykit. There you go. Now we have the MRUK room, and if we do room equals MRUK.instance.get current room, there you go. This will give us the data for the current room, but of course there might be an issue right there if the MRUK room is not set up or initialized. So what we can actually do is in the update function, if MRUK.instance, if there is no MRUK.instance and that MRUK.instance is not initialized, then we can simply return. So this will make sure that the room is in fact initialized. Now anyway, with the room data that we have, this is where we can use some magic, because there is a very important function inside the MRUK room, and it is room.generate random position on surface. You can even see that there is a one for random position in room, but the one that we are looking for is the random position on surface. Beautiful. Now, as you can see, the script needs multiple parameters. The first one is the MRUK surface type. And as you can see, we can set if it's facing down, up, or vertical. Now, in our case, we want it to be vertical because we want it to be the wall. Anyway, now, as you can see, the second parameter is the min distance to edge. So we can give this as a parameter over there, like public float min edge distance, and we can set it maybe to 0.3. There you go. We can set it as a parameter for the second variable. Then it needs, as you can see, a label filter. Basically, it will tell you which are the labels where we can generate the position. So for this, we are going to go at the top and we are going to add after the mid edge a public MRUK ensure dot scene label that we can call spawn label. There you go. Now over there, we can do label filter dot included and then give our spawn labels parameters. Beautiful. And now, as you can see, yeah, let me scroll down so that you can see everything. The two last parameters are simply the output, so the position and the normal. So let's do out vector3 pose and then out vector3 norm. And as you can see, with this simple line of code, we are able to generate a random position on the surface, which is super cool. And now from this, we can actually use the position and the normal to kind of spawn behind the wall. So if we do, for example, let me simply do random position normal offset. And what we can do is, instead of using this, we want to write the pose that is output and then do plus norm. So the normal of the surface multiplied by a certain offset. So let's write it at the top. Public float normal offset. There you go. And we can write it over there. Normal offset. Beautiful. Now that we get a random position, we can set the height to be 0 as well, which will be handy. And then we can use this random position normal offset as the second parameters, and everything should be great like this. So let's find out how this works by saving and going back to Unity. There you go. Now for the spawn label, we want the spawning to occur on the wall. So let's select only the wall face. But of course, you could select any surface that you want the ghost to spawn on here. And now right there, if we click on play, let me select the bedroom so that you can see the shape of the room. And as you can see, it works. We are able to generate a random position on the different wall of our scene, which is awesome. But that's not it. So let's leave play mode. And what I'm going to do is set the normal offset to maybe -1. This way, this means that the ghost will spawn 1 meter behind the wall. So let's click on play to find out if this works. There you go. And as you can see, it works. We are correctly spawning all of the ghosts outside of here, the scene model, which is exactly what we are looking for. Okay, so right now we kind of have a big issue with our ghost spawning, which is not always seen, but we are here generating a random position outside of our player environment. But what if we are not able to find this random position with the setting that we've set? And this is a big issue, right? And so let me show you how we can easily fix it. So if we leave play mode and that we go back to our script. Now, as you can see, this generate random position on surface return a Boolean value. And this Boolean is true if we are able to find a random position with these settings or not. So what we can do is write bool as found position equals to room.generate. Now, if we indeed have found the position, then in this case, we can do what we've done before. But what if we haven't found anything, right? This means that we won't be able to instantiate or prefab. So this would be a big issue because we kind of need to spawn something. So instead, what we can do to fix this issue is give a certain number of try. So if we go at the top and that I write public int spawn try, we can maybe set it initially to 1000, which seems big, but it should never get to this kind of number. Now, anyway, what we can do is at the top, when we spawn the ghost, we can do int current try and set it to 0. And what we can do is then while current try is less than spawn try, then in this case, we want to still generate the room. And if we have found and position, there we go, we can instantiate and everything is nice, and we can even return at the end so that we stop this while loop. But if not, we can simply increase the number of try by doing current try plus plus. So I know that this is maybe a weird logic right there, but keep track that maybe the as found position doesn't work. So what we need is to have a certain number of try before we fail so that it will work most of the times and will reduce the amount of error that we can get. This is why we are doing this while loop here that will keep generating position until we have found a good one. But anyway, with this, we should have a very strong spawning system. Now, as you can see, there were two important things. First, the generate random position, and then using a system of spawn trials to make sure that we are able to find a random position. Now, anyway, let's save, go back to Unity, and let's build and run our game to find out if this works. And there you go, guys. As you can see, the ghost now correctly spawned behind the wall of the players randomly, using the little ghost spawner script that we made. This video was super fun to make with some things that I don't show a lot in my other video, like 3D modeling and making shaders, so I hope you enjoyed it. In the next episode, we will learn how to navigate our ghost in the player environment to avoid obstacles, so you better subscribe to not miss it. A big shout out to the new Patreon, which are appearing on the screen right now. If like them, you want to get access to the source code of this game and other exclusive content, join us, link in the description. A big shout out to Cognitive 3D for sponsoring this series. So if you'd like to know more about your game and better understand your player, you can try the tool for free by registering with the link you will find in the description. Thank you so much for watching and see you in the next one.